This video explain the wind load example. The example is industrial building. So one is to be built in a rural setting on the outskirts of Canberra. So the location is Canberra. Determining the wind force for the strength limit state on the roof and wall of the typical interior frame. The roof has a pitch of 7.7.5 degrees. So the pitch is 7.5 degree here. The frame are at 6,000 millimeter center to center distance. So we have a frame here which is the 6,000 millimeter center to center distance, and the height of the eaves is 5,000 millimeters. So height of the eaves is 5,000 millimeters. The door for the buildings are shown, and there is a fixed roof vent with 130 millimeter airways for half the length of the ridge. Consider the two cases where all the opening except the roof vent are closed and critical openings are open. Now it has a site plan given, which is the orientation of 15 degree from the north. It is 24 meters wide on this side and 16 meters wide on this side. Location of door D1, D2, D3, D4 and D5 given. The dimension of the doors are also given here. Now this is isometric view. There are some details given here at the back. So the isometric view of these buildings are shown in this figure. So if I take the section, for example, one cross section here, it should look like, if I'm looking from this side, it should look like these sections. Now elevations, if I look from this side, I should able to see 1, 2 and 3, 1, 2 and 3, and this image I can see it here. Roof plan, if I'm looking from the top, plan is looking from the top, then I'm able to see 1, 2 and 3, 1, 2 and 3, and all these 9 square here. End walls, that is the end wall. If I'm looking from here, I can able to see these end walls with these three sections. So let's start solving these examples. Now first steps, we need to find site wind speed. So we have an equation to find a site wind speed. Site wind speed beta is equal to VR, MD, MZ cat, MS and MT. Now these equations can be found in the clause 2.2. Clause 2.2 of AS NZS 1170.2 2011. We have this site wind speed VR, MD, MZ cat, MS and MT. So now we are going to find all these variable one by one. VR except MD, because MD has 8 different value depending on the directions, and all others values are constant. So we are going to find 1, 2, 3 and 4 parameters in here. Now first of all, we need to find the reference height of the building. So if I draw the cross sections of the buildings, which is these cross sections of the buildings, which can see here 16 meters, which I draw 16 meters here, 5 meters here, 5 meters here. Now the reference height can be located in the middle of these inclined lines. So now how can we know that where is the reference line is located? Now the reference height can be found in the figure number 2.1 on page number 9 of AS NZS 1170.2.1. Now this is the structures look like. So in that case, the reference height, if the wind is blowing from these sides, we have a reference height of h here. So that's what I draw here. So that would be half of these two. Now the pitch 7.5 degree is given in the questions. So if I can read the questions here, 7.5 degrees roof pitch is given. So that is roof pitch 7.5 degree. It's located here. If I draw the horizontal line here, that's angle is 7.5 degree. So 7.5 degree. Now I'm interested to find this height, so I can use the 10 ratio. So 10 7.5 is equal to opposite over adjacent, y over x, and then 7.5 is equal to y. And as you can see, this is the symmetry triangle 7.5 here. So I can say that this length is 8 meters, half of shifting, this is 8 meters. Substitute x is equal to 8, so y equal to 8 times 10.7.5 degree is equal to 1.05 meters. This is the height, 1.05 meters here. Now we are interested in looking at this half. So 1.05 divided by 2 give us 0.5 meters. which is 0.5 meters. So if I'm looking for this height, reference height h, I can have 5 meters plus 0.5 meters. So 5 plus 0.5, so the reference height is 5.5 meters. So that's the reference height. And if you need more information, that is given in figure 2.1 on page number 8. That is here, figure 2.1 on page number on the page number 9. On figure 2.1 we can find the typical structures that is given here, I think here on the page number 9. Now once you find the reference height, we can find the region, where the region is located. Now in the question is given in the Canberra. Now the building is located in the Canberra, is given in the questions. Based on this information Canberra, we can check page number 17, sorry. So on page number 17 we can have a Australia map. On the page number 17 we have Australia map. On the figure 3.1 wind regions, we can locate the Canberra here, that is Canberra here, and in Canberra there is a region A3. So for this case we have a region A3, that is on page number 17 on figure 3.1a. So we found the reference height and we found the region based on the location of the building. Now the second, we like to find the MZ the terrain height multiplier. Now we can assume the terrain category 2 is not given in the questions, but normally we can have a terrain category 2. Now that information is given in section 4.2.1 on page number 19. So if I can show it here, most of the information is given about the various terrain category. You are allowed to read these terrain categories. So we are taking this terrain category TC2, which is open terrain including grasslands. So that is typical case that we are considering here. So terrain category 2, that's I take it from the section 4.2.1 on page number 19. Now we need to find the MZ. So if you look at the table number, let's say on the next page, if you have a on page number 20 on table 4.1, it has given various terrain MZ value. Now we assume terrain category is 2, so we are looking at here, and the height of the building is 5.5, right? We just found it. Height of the building is we find the height of the building is 5.5 meters. So based on that height, we need to find the MZ value. So in here we have given the value 5 meters and 10 meters. We don't have 5.5, so we need to interpolate between 5 and 10. So the interpolation given here. So height is 5 meters, which is taken here. 5.5 we need to find, and 10 meters here. So 10 meters I find it here. Terrain category 2, 0.91 and 1. So that is 0.91 and 1. Now to do the interpolation, we are interested in finding this 5.5. What is the MZ value? That should be between this and this, right? Between 0.91 and 1.0. Now here we can say x1, y1, xy, and x2, y2. x1, y1, let's say 5 and 0.91. xy is 5.5 and y we need to find. Let's say x2, y2 is 10 and 1 for y2. So the interpolation equation is y equal to y1 plus y2 minus y1, x minus x1 over x2 minus x1. We substitute the value 0.91 plus y2 1, take away 0.91 times x 5.5, take away 5, x1 5 over 10 minus 5 for x2 minus x1. So that mathematics gives the 0.91 using the calculators. Now that is the terrain height MZ value. Now next one, we can find regional wind speed. Now to find the regional wind speed, we can say that is normal buildings, and we already found is the region A3 for Canberra. I already saw in the previous steps. And from table number 3.1 on page number 15, I can show it here. From this table 3.1 on page number 15, table 3.1, regional wind speed for the return interval of 500 years, we have 45 meter per second. The unit is meter per second, so that is 45 meter per second. That's the value for regional wind speed. So VR is equal to 545 meter per second. Now next one, we like to find the wind directional multiplier, MD. Now the wind direction multiplier has 8 different values. So that is given in the I think in the table number, the wind direction multiplier is given in the table number 3.2 of page number 16, and we are in the region A3. For region A3 we have 0.85 for north, northeast 0.8, east 0.8, 0.8, and we copy all these 8 value respectively for region A3 for the 8 different directions. That is given in the table number 3.2 on page number 16. Now shielding multiplier, there is no shielding effect is given, so ms equal to 1.0, that is given in the clause 4.3 on the page number 21. So if you are look at this clause 4.3 on page number 21, the information is given about the shielding multiplier. And topographic multiplier is empty, so that empty equal to 1.0, that's located on the flat ground. I think it's given in the questions that building is located on the flat ground, so empty equal to 1.0. that is information given in clause 4.4 on page number 22. So if I look at this one on here, clause 4.4 topographic multiplier on page number 2, the information is given. Now the next one, the last one is the side wind speed, V side beta. Beta is a different direction, 8 different values. VR, MD, MZ, MS and MT, we are going to substitute. We found VR is equal to 45 meter per second, so that is 45 meter per second, we found it. MD, we have different values, so we are not substituting right now. MZ 0.92, we found MZ using the interpolations, we found that one 0.92 in this previous step. And then we have MS and MT 1 and 1 that we found here in the previous step. So MS equal to 1, MT equal to 1, multiplication give 41.4 times MD. In the next step we will solve this example further. Thank you very much.